Hello, I'm Lisa Baptiste, and today I'm going to talk to you about the contiguity principle in multimedia design, reducing cognitive load in e-learning. So what is e-learning? According to Clark and Meyer 2023, e-learning is delivered through a digital format for the purpose of building knowledge and skills designed to be used in asynchronous or synchronous settings. So when we talk about asynchronous, we are talking about a learner-paced instruction. So looking at the diagram that's shown here on this slide, things like learning at home, that would be asynchronous. The reading, this person's reading digital media, but they're by themselves, so that would be asynchronous. Taking an online test or getting a certificate online, that would be asynchronous as well. And then when we talk about synchronous, that's instructor led. So instructor led would be things like right here in this classroom, you see the teachers using digital media to teach the students. That would be synchronous. You see there's a podcast in the picture and you see a group of students that are viewing this podcast. That would be synchronous. It's an instructor led and all that are involved are meeting at the same time. Another example would be a webinar because all of the parties are viewing that webinar at the same time. So that would be also an example of synchronous. So why the need for e-learning? E-learning is needed because during the pandemic, the COVID-19 pandemic, because of that major worldwide shutdown, there was a great need for online instruction or e-learning instruction. And so at the time, because of the rush to meet the demand, e-learning was not structured so that it was student focused and student centered. And so researchers have come along to make sure that moving forward, e-learning instruction is student focused and it meets the needs of the students involved. So there are some disadvantages to e-learning, one being cognitive overload. When we talk about cognitive overload, it could be that there's so much information that is given to the students that they're not able to take in that instruction and really pinpoint the key points that are needed for the learning. Or it could be limited engagement. It could be good material. It could be meeting the core values and the goals of the class. But if the student is not engaged in the material or does not have the opportunity to be engaged in the material, then that will limit the amount of e-learning that takes place. There's also lack of training. So if the faculty are not properly trained on new programming, new resources that are available or that are offered to the students, it hinders them from being able to teach the students how to use the equipment or to use the new programming properly. And then technology fads. There's some new and innovative technology that is wonderful in certain settings, but does not meet the needs of every educational goal. And so it's very important that the designer, that the educator use the technology that meets the goals for the class that they are working with. And then there are advantages. Advantages outweigh those disadvantages in e-learning. One being rich multimedia. There's so many resources available for educators, for designers, that it's very important that they take advantage of this rich amount of resources that are now available. Customization, they can customize the multimedia to fit their particular educational goals, and so it makes it beneficial for them. Engagement and feedback. So there's so many opportunities for students to feel engaged in their educational process and in learning their and meeting their educational goals. And then feedback from faculty is very important and a great advantage of e-learning because they can give them one-on-one feedback and tell them things that will help them improve as well as things that they are already doing very well. Acceleration of expertise. There are different ways to do simulations to learn new products and new ideas, to get that personal training that may take years if they were in a classroom setting, but they're able to do it more quickly, excuse me, in an e-learning environment. And then the availability of collaboration. Collaboration not only within their school themselves, but collaborating with different people around the world through social media and through different internet available tools that will help them to understand material and look at different educational goals through the views of other people. So, what's the application of e learning? So, the contiguity principle, cognitive load, and multimedia, these are things that I will define and talk more about in this presentation. But the contiguity principle helps with reducing cognitive load and increasing the amount of learning that takes place. And I'm going to show you how that does. And then applying the contiguity principle in the development of multimedia and in e-learning reduces cognitive load. And I'm also going to talk about that. So the multimedia principle, what is that exactly? This is learning is more effective with words and graphics than with words alone. So for example, if I were to teach someone about kneading dough, okay, and I tell the class that you're going to fold the dough over and then you're going to take the bottom portion of the palm of your hand and press down into the dough. So in your mind, you can kind of picture what I'm saying if you understand the making of bread and kneading dough. But say, for example, you've never seen that before and you're confused as to what exactly that means. So the words that I gave you may have you scrambling and trying to think of what that might look like, or the picture that you're trying to grasp the image of. What you're doing is creating more of a load on your brain, trying to figure out what exactly I'm talking about with those words. But say I take those same words and I show you a picture. So you can see in the picture the dough being folded over, and you can see the bottom portion of the palm pressing into the dough. And so now those words that I've given you make a lot more sense. And so it's easy to visualize. That's the purpose of multimedia. Being able to take the words, whether they be written or spoken, and apply it to a picture or graphic. It could be a chart, and showing the reader or the learner how those two go together and making it a little easier to see. Okay, it lightens the cognitive load. So what are the different graphic types? So there are decorative, there's representational, organizational, relational, transformational, and interpreted. So if we're talking about a decorative graphic, it adds a pleasing appearance or humor, such as an illustration of a chemistry joke at the beginning of a lesson. So if I were to give a chemistry joke at the beginning of a lesson, it may or may not have anything to do with the lesson. It just might add humor and lighten the load of a difficult task that's going to be taught. And so, for that reason, decorative graphics sometimes add a distraction to the learning and are not as beneficial as some of the other graphic types. Representational graphics are pictures showing what an object looks like. For example, a labeled diagram of a heart. Right? Organizational graphics show qualitative relationships such as a concept map or a tree diagram. Relational graphics, they summarize quantitative relationships such as a bar graph or a pie chart. And transformational graphics, they illustrate changes in time or space, such as a time-lapsed animation or a video demonstrating a specific process. And interpretive graphics that make items or processes not visibly seen visible as a molecular structure or body functions. So, how do we apply these graphics? And so we can organize the content, we can show quantitative relationships, or interact with the lesson. So, tables, flowcharts, and concept maps are all great examples of graphics that organize information for a lesson, which can be used to introduce material for a lesson. Maps and graphs can be used to show the numerical relationships between two items in a lesson. And finally, simulations that are interactive lesson interfaces can be used to teach students how to perform a certain task. And as they are reading the lesson, they are able to perform the task within the graphic. So now that we've looked at the graphic and multimedia, I talked about the term cognitive load theory. And so, what is that exactly? So, that is the mental effort that students use to learn material. There's other terms like mental load and cognitive overload that are associated with cognitive load theory. The mental load is the amount of memory students can retain, and the cognitive overload is when the students try to add on more memory than the mental load. This leads to being frustrated and overwhelmed. And so the goal is to design material that reduces the mental load and avoids cognitive overload. So, how does the memory work? And so if we think about a multimedia principle, a presentation, we start off with words and pictures. And you see the arrows pointing toward the eyes as well as the ears. That is because the words can either be a text, which you would see with your eyes, or it could be audio, which you would hear. All right. If it is audio mixed with a picture, then your words are going down one channel, the pictures are going through another channel. This is called a dual channel process. And this dual channel process is important for reducing cognitive load. And so the words go through the ears, all right? These are our senses that are detecting this multimedia presentation. If we're selecting the words, okay, it goes into the working memory. And it's important that what our students are viewing are going past the senses into the working memory, because that means that they are paying attention to what they're viewing in that presentation. So once it's gotten into the working memory, it is processed as sound, all right? And once it's processed as sound, then the brain has some options here. The option is to either organize those words to be further processed into long memory or to forget, all right? But our goal as educators is to have the students go from the sound that they hear from the words, organize those words into a verbal model. All right. So let's go down to the pictures and then I'll bring them all together. So the pictures, the learner is going to see with their eyes. All right. And again, just like with the words, the student has an option of either selecting those images to put it into working memory or forgetting about it. All right. And so our goal, of course, is we want our learners to select those images. Once they've done that, it becomes into the working memory. Once it's in the memory, working memory, again, they have the option of either organizing those images or forgetting about it. All right. Again, we want them to organize it. So if we're organizing the images, they become the pictorial model. So the verbal model and the pictorial model, excuse me, if they're integrated with prior knowledge, then they can move to the long-term memory. Excuse me. Sorry about that. So once in the long-term memory, then that multimedia presentation becomes something that they store in their memory. Once it's in the long-term memory, it can be used in order to do assessments based on that presentation. So types of cognitive load. So we talked about how we want to reduce the cognitive load and we want to improve learning for our students. There are three different types of cognitive load. There's intrinsic load, extraneous load, and germane load. The intrinsic load represents the difficulty of processing new material regardless of how the material is taught. The extraneous load, it deals with how the new material is presented to the learner, which determines the ease of learning. And germane load pertains to the effort and mental capacity needed to learn new material, memorize, and organize the material for storage in the long-term memory. And we talked about that in the previous slide on the importance of being able to organize and store it in long-term memory so that the learners can use it for taking assessments based on the learning goals. So there are challenges of cognitive load theory. We have interactive learning media, and that is an online learning material in which the responses are generated by the computer. This can be in the form of a simulation program that gives feedback on students' responses. Then we have immersion. Immersive quality media blocks out the external environment and places learners in a virtual reality environment. Realism is used for creating realistic graphics to make the digital environment believable. These graphics can increase cognitive load due to the complexity of the graphic. So it is important that if using these different graphics that increase cognitive load, that we decrease different areas of cognitive load so that students go into overload and the information that is given to them becomes ineffective. Defluency is the act of increasing learning performance by adding distractions in the learning material. For example, making fonts or images less readable. And the purpose of that is if you're making certain things less readable, it makes the students really focus in on the information so that they can better understand it and better grasp the learning. And finally, emotional design, which is introducing visual cues to trigger positive emotions, can enhance learning. Finding a way to get the desired concepts to the students that does not cause overload and is deemed important enough to keep, while minimizing distractions is an important part of multimedia in education. So now we're going to talk about the contiguity principle. What it is it lowers cognitive load by placing the graphics close to the text that describes it. Because remember, in multimedia, we have the text, we have the graphic, but we're understanding as we learn more and more about research that not just having the picture and the text together is enough. The how we place that graphic in relation to the text is very important. I'm going to go through some examples. So the first one is spatial contiguity. All right, so if we look at this picture, we have a picture of the brain and then the four parts of the brain. And we see that we have the parts numbered and then they correspond to the numbers here, which give the names. So if we look at this, if we're looking at the picture and we look at this part, this is, we look at the orange part, it's numbered 1. And then we have to go to the left to see what number 1 is called. Then if we look at the green portion is number 3, we again have to go back to the chart to see what the name is. If we look at the yellow portion, which is number 2, again we have to move to the left to see what that is. And then for the blue part, we have to again go to the chart to see what that is. This separation between the diagram of the brain and the names of the different sections of the brain, scientists have said that this separation increases our cognitive load. What is suggested is to actually place the labels on the parts themselves, and the proximity of the words to the diagram makes a big difference in the amount of cognitive load that is used by the learner to understand the different parts of the brain. That is spatial contiguity, how close those words are to what they are labeled. So then there's temporal contiguity. So if we take that same diagram, all right, we have the brain. And so we show the picture first, and then say on the next slide, we show the names. All right. According to temporal contiguity, that is when there is a separation in time. All right. The spatial contiguity deals with separation in space. Temporal contiguity represents separation in time. And so it's more important that if you're having the information that talks about the graphic on separate slides, it increases the cognitive load. It is better if they're on the same slide. This is why, because if we looked at the picture first, right, and then we get the key that tells us what the names of those different parts are, our mind has to remember where in the brain diagram those different numbers were. And that increases the amount of memory that we use up to try to remember where everything was and then associate those numbers with the names. The contiguity principle research. So there was some research that I looked at for this particular presentation. So I want to go through a few of these. One is done by Farkash et al. 2022. And their group compared the results of using multimedia with principles of signaling, coherence, spatial contiguity, temporal contiguity, and redundancy, and without principles to see which is more effective in learning. They felt that there was a need for more effective assessments. To achieve this, they used electroencephalography, or EEG, to measure physiological effects of the learning process. This quantitative measurement of the EEG they felt was more reliable, and students in the research of Farkas et al. 2022 were placed into two groups, one that used multimedia design principles in their learning and one that did not. Each group watched the lesson while an EEG measured brain activity. At the end, a comprehensive test was given as well as a cognitive workload questionnaire. Farkas et al. 2022 found that the group with the multimedia principles showed lower cognitive load, with signaling and spatial contiguity having the strongest impact. Another research team, Polpoli 2022, analyzed genetics animation to see if they followed the multimedia learning principles, signaling spatial contiguity and temporal contiguity to increase effectiveness of visual learning aids. In this research, genetics animations were analyzed for how they related to the different principles of multimedia theory. Popoli 2022 used 17 videos that covered genetic topics for a biochemistry course. The purpose was to assess the ability to reduce extraneous cognitive processing through the frequency and patterns of principle compliance and violations of the multimedia design principles. They found that 56% of the animations examined followed multimedia principles and the rest did not. For the ones that did not, they lacked signaling, spatial contiguity, and temporal contiguity. This led Popoli 2022 to stress the importance of design in learning and ensure that material used must follow the multimedia principles. These et al. 2022 use an experimental group with augmented reality AR and a control group with separate display to test spatial integration in learning. They hypothesized that the head-mounted display AR lab work would lead to reduced extraneous cognitive load and yield higher learning gains. Unfortunately, the hypothesis of Thies et al. 2022 was proven to be incorrect. They found that higher learning and lower cognitive load was found in the separate display group. In the research of Sci 2022, the research had two groups. One used virtual reality. However, their control group received instruction from a live person, no electronic device. This group showed more favor to the VR group, virtual reality, showing that multimedia usage shows favorable results for VR technology. Since the control and experimental groups for Thies et al. 2022 were given material that fulfilled spatial and temporal contiguity, this still proves that instruction using the contiguity principle improves learning and lowers cognitive load. Yang et al. 2023 investigated the effectiveness of the spatial contiguity principle in multimedia learning by looking at how close the graphics need to be in relation to the text to be effective in learning. As you remember, I talked about how it is important that the graphic is close to the text in order for it to be beneficial to the student. They hypothesized that text and graphic information given in the perifoveal view is better for spatial contiguity than information in the peripheral view. Yang et al. 2023 used eye movement calculations to compare the two visions. One group saw the text and graphics in the perifoveal and the other in the peripheral. The information shown was the same, and each group received a questionnaire at the end. Yang et al. 2023 found that perifoveal view promoted better integration of text and picture. This view also improved the learning outcomes and reduced cognitive load. So, what was shown by all researchers is the importance of spatial contiguity on reducing cognitive load and improving learning, thus giving evidence that applying the contiguity principle in the development of multimedia in e-learning reduces cognitive load. Here is a list of the references used, and thank you for your time.